going. So yes, so we have, this is our 12th event now, and going from strength to strength, I think being online really helps because we can bring people in from around the world. And this time of day seems to be ideal for a number of time zones. Right, so welcome. I'm Neil Strange. I'm the chairman of this user group. We helped set this up. I actually run a small company called Data Vault. We do consultancy on Data Vault, based in the UK now, but increasingly working with clients all over the globe. And we sponsor this event. So great to see first timers out there. Welcome. If you want to check out earlier events, then please do go to the user group. There are links there to previous 3 events on video and slides for all the other events available to download if you're interested. In terms of the meetup, we now have over 600 members, which is really good. We're growing up there, becoming one of the more populous user groups in the London area anyway. We have a website, so very long URL, ukdatavaultusergroup.co.uk. Please do visit that and check us out, where you say presentations are available from previous meetings. If you weren't aware, if you're interested to learn more about the Data Vault, we have a free 2-hour session we run every Thursday. Please do check us out. It's on the link below. You'll get a copy of these slides, so you can download these slides and link from there. But it's also on Eventbrite. If you search for Data Vault Core Concepts, you'll find us. We're kind of booked out on there for the next 5 weeks, but there are free slots available going forward into the early part of December. So please do check us out and book in if you want to learn a little bit more about the Data Vault. We run them at different times of the day each week. So 1 week we run it early morning, 1 week we run it in the evening to catch different time zones. So it's very popular. We've currently sold at least 100 tickets ahead on this. Future events. We've been working very hard to get future presenters on board. So I'm happy to announce today, and this will be up on the meetup for you to register and register your attendance to. But in November, we've got an event with Snowflake. So we've got our good friend Kent Graziano presenting. He'll be with a local consultant here we all know very well, Dmitry Yaroshenko from Snowflake in the UK. And they're going to talk about Snowflake's latest features and how they can be used on Data Vault projects. In December, we've got a panel of experts coming in, so experienced Data Vault practitioners, and they're all going to talk about things they wish they'd known before they started their first Data Vault project. So we're going to have them present 3 things they wish they'd known each, and then a panel session at the end of that. And you're very welcome to join us for that, and maybe a beer or something afterwards to celebrate early Christmas. And then in January, Dan Linstead very kindly has volunteered to present on the future of Data Vault. Now, we haven't got it up yet, but in February, we've got a presenter coming in from a NASA-owned company who's going to talk about data science with space data sets and the importance of data management on space data. And in March, we've got a presenter coming in to talk about shared data sets, government shared data sets, and how they're managed behind the scenes and published to the public to access. So we've got the next 5 events now queued up, and you can start registering for them now if you go to that meetup link below.
Sure, my name is Drew Banin. I'm one of the co-founders here at Fishtown Analytics, and I operate as the head of product. I actually saw one of my colleagues, Simon Odekirk, is on the call as well. He's in the PM on my team. So we're in the chat. I do encourage everyone to ask questions as you have them throughout, and maybe we'll stop and address them or circle back at the end. And I'll see if I can find my chat window. Yeah, I got it. Perfect. So yeah, I'm based out of Philadelphia, Pennsylvania. Have spent a good amount of time in London over the years, kind of working with Fishtown Analytics. doing DBT community meetups. And so kind of a fun fact about me is that my favorite beer is Camden Lager. If you've ever had that one, I really enjoy it out of London. So we're going to get into it. Today I'm going to talk about, why DBT, kind of give an overview of how we see the space evolving, DBT's role in the modern data stack. Teasing something a little bit later, we're going to do maybe a bit of a live demo. Certainly I would love to hear kind of what things people are hoping to do with DBT, or maybe what questions you have. So we'll have lots of time for questions at the end. So to start us off, to understand why DBT exists, what role it serves, you really need an appreciation of sort of how this data transformation landscape has changed over the past, say, 5-10 years. And really the big paradigm shift is the shift from we call it ETL to ELT. And so the old ETL workflow, this is kind of old school. It's how things have worked, really for the lifetime of analytics, is that you kind of extract your data from all your data sources, you sort of transform them in memory on a server somewhere. You take that transformed data set and you put it in your data warehouse or database, as it were. So that's sort of become inverted recently. And really, we can attribute that to the rise of these really incredible data warehouses like Snowflake, Redshift, BigQuery, and there's more too. Because these warehouses are so powerful, you don't need to pre-aggregate and pre-transform your data before loading it into the database. Instead, the warehouses, basically all of them you pay by usage. So if you say add another terabyte of data to Snowflake, it's 20 extra bucks per month. It's a pretty good deal. So you can just load all of your raw data into the warehouse and then sort of apply your transformations in the warehouse using SQL. So that's sort of the backdrop of how DBT has come to exist. And yeah, I see schema on read versus schema on write. That's exactly it. You get to decide how you model your data with it already in the warehouse instead of trying to apply those transformations kind of in stream. So why ELT? Truly, these modern data warehouses are just incredible. They are cost effective in a way that data warehousing has never really been to date. Like, people don't use the words cost effective when they talk about databases like Oracle and Vertica and Teradata. But Snowflake, Redshift, BigQuery, really you can scale them up and down with your usage. Pay more if you use more of it. So that's one part of it. The other part is bringing the compute to the data. So if you're doing data warehousing, and taking analytics seriously, it's sort of a given that the amount of data you're going to be processing will increase over time. It's like every day new things are happening in your business. So what you probably don't want to do is have these really large data processing servers where, say you're rolling your own with something like Airflow in Python maybe, or alternatively, maybe use an off-the-shelf product like, say, I think Talon does things like this. The idea of taking your data out of the warehouse and then transforming it on a server somewhere, and then loading taking your data from a data source, transforming it on a server, and then putting it in the warehouse, it's like probably not the optimal way to do this from a performance and cost perspective, because the data warehouse is where the data already lives. And so if you can apply computation to the data at rest, that's going to be probably faster, cheaper, and all around easier to sort of manage. We'll talk about that a little bit later. So certainly there's kind of cost benefits to doing it this way, but kind of the bigger things to talk about here are the like human costs, right? So one of the great benefits of this sort of ELT paradigm is the flexibility that you have in defining your transformations. So if you've got all of your source data in a warehouse and you decide that yesterday you were going to define an active user one way, and then today you want to define it a different way, you don't have to replay and restream your data out of your data sources. You've already got all of your source data, and you can choose to define your sort of business definitions differently if you want. So there's a lot of flexibility in this model, and collaboration is also really key. It's super easy to get lots of people access to a data warehouse and control permissions very granularly in a way that would be a lot more challenging, say, if you were rolling your own ETL in Airflow. It might be tough to get lots and lots of people access to, kind of deploying new Airflow code. Whereas if this is kind of all happening in the warehouse and it's all based on SQL, You can have lots of people either contributing to sort of your analytics process, or at least being observers and stakeholders of the process, being able to see like, tables and views in the warehouse and understand what's happening where and how transformations are applied through the pipeline. So that's kind of the backdrop, is the shift to ELT, really powered by data warehouses. And about 4.5 years ago, when we started Fishtown Analytics and started building DBT, Redshift was kind of the database. In the past, say, month or so, we've seen that Snowflake has really taken off, both in terms of usage and in terms of like stock price. So really, it's all about the warehouse and the power that these warehouses provide. So what does DBT do? How does it fit in? Well, DBT is going to be able to create, test, and document data models inside of the warehouse. So what's a data model? I don't have to tell you all about the importance of modeling your data. This is the Data Vault group. So, of course, there are different kind of paradigms. There's Data Vault, there's Kimball, there are more still. And you can also choose to, shirk one of those paradigms and kind of do things your own way. And if that's the right thing for your business, who am I to tell you otherwise? But when we talk about data models, we're kind of specifically talking about all these tables and views that are created in your warehouse as logical abstractions. So the idea is your source data is going to be what we call source conformed. It is, in whatever format your data source provided it to you in, loaded in your warehouse. But if you want to do analytics on this, you have to apply a lot of logic to sort of, here's a good example, like define what an active user is, or define how you calculate your monthly recurring revenue for your business. So we call all these things data models, and DBT helps you create, manage, test, document, and expose these data models to consumers in your company. So in DBT, data models are expressed as SQL select statements. DBT has a sort of framework that supports testing these data models. We'll take a look at that a little bit later. And the really exciting thing about DBT is it allows these data models to depend on each other. So if you take a sort of web analytics, example, we're going to start with, say you've got clickstream events. You want to transform those into page views, and then you want to take those page views and transform them into web sessions. You want to take those sessions and maybe convert them into overall user-like dimensions, things like that. DBT helps you build these transformations in a way that they can stack on top of each other. And we'll see an image of that too in a second. So we call this thing a directed acyclic graph. We'll see an example in a second. It's sort of a computer science topic, but it comes up a lot in sort of data preparation and transformation, because you do have these processes that depend on each other. So DBT helps you run and test these parts of, like different parts of the DAG, and also it will intelligently parallelize running all of your transformations. And so the other thing to say about DBT is at its core, it is Apache 2.0 licensed open source software. We also have a sort of hosted SaaS product called DBT Cloud that we operate. Overall, DBT has a super vibrant and highly engaged user community. You can join us on Slack if you're not in there already. We have a data vault modeling channel. You can find us at community.getdbt.com, and I'll share a link to that in the chat a little bit later. Okay, so when we talk about DAGs, this is kind of the thing that we're talking about. And this is a DAG visualization that DBT can render for you automatically. So what we're looking at here is actually our DAG, our DBT project at Fishtown Analytics. And this part of the DAG shows how we calculate our revenue. So we're a 4.5-year-old startup. We're pretty unencumbered by technical debt, all things considered. But even for us, we've got this really fascinating scenario where DBT Cloud has sort of a self-service tier. It's $50 per user per month, and you can pay with a credit card and start using it. That's going to be recorded in our Stripe data sources. But we also have an enterprise tier, and for those we do annual invoicing. So the really funny thing about us is we used to be an LLC in America, and now we're a C Corp, or we're incorporated. And so we have, in fact, 2 different QuickBooks accounts. So if you want to answer the question, even for our small, nascent startup, if you want to answer the question, how much money did we make last month? It's actually a pretty challenging calculation. You have to combine self-service Stripe data with subscriptions, and then combine data from 2 different QuickBooks data sets, one from our LLC days and one from our C Corp days. So yeah, we're going to zoom in here. You can see these green nodes here in this graph. We call it directed acyclic graph. These green nodes are data sources. So we've got QuickBooks invoices, and here we've got QuickBooks customers. But we've also got QuickBooks Inc. invoices and QuickBooks Inc. customers. And so if you want to sort of marry those 2 things together, you have a decision to make. You can either encode that business logic in every single analysis that you ever do when you try to report on revenue, which would be onerous and error prone. Or you can use something like dbt to create this data model and say, in our case, we've made stage QuickBooks invoices and QuickBooks Customers Union. This is just part of the DAG, but we sort of use a Kimball light modeling approach. Hope you'll forgive us for that. So the big idea here is now we have these logical abstractions over, invoices and customers for QuickBooks. And if we're ever curious, what are our enterprise sales, invoicing numbers? We don't have to do a union across 2 different source tables. We just have the abstraction ready for us. It's just customers and just invoices, and they're union together already. Cool. So, and I see some good questions. Maybe we'll keep going, and then I'll take a pause to talk about some of those things. So why do we go out? Why do we build dbt, right? And really, it's a tale of 2 workflows. So my background's in computer science. I was, in application development previously. I guess a fun fact is that I wrote a lot of the early open source code for dbt, so I'm kind of no stranger to building applications. When you're building an application, you use version control, you do code reviews, you have auto-generated documentation produced from your code. There's automated testing to make sure that you don't regress and break something when you're making a new change, or to validate that your new change works correctly. And then there's also generally a notion of continuous integration and continuous deployment. And so we can talk a lot about this, but the big idea is when you open a new change request, in GitHub, it might be called a pull request or a merge request in GitLab. When you open one of those pull requests for, an application, typically it'll kind of build your application and run some tests and validate that all your checks are passing. And, this is really pretty common for applications. But if you take a look at the sort of analytics development workflow, it can be a lot more like the Wild West, right? So you've got tables in a warehouse and you don't know where they came from. You don't really have a staging environment. You just do a lot of things in prod. Documentation frequently looks like ad hoc conversations. And yeah, there's not really a notion of testing that happens reliably in an automated fashion. Instead, you might just kind of run a couple spot checks and see if everything looks about right. It can be really easy to regress and break something without realizing it. So that's really the sort of core impetus for us creating dbt is we want to take the analytics development workflow and make it look a lot more like the application development workflow. Take all those benefits of decades of thinking about how to build applications well, apply to analytics. And I don't know if you can hear the banging, but I'm sorry about that.
We can.
Apologies. Okay, so let's talk about the analytics development workflow that you can enact with dbt. So in dbt, you create these data models, and they're just SQL select statements. And because they're just SQL statements and text files, they're very readily version controllable. You can version control these things in a way that you can't really version control like a drag and drop, set of transformations, like maybe you might see in, say, like SSIS, which is a tool that I've never personally used, but have seen pictures of before. You can't, maybe you can, but it would be hard for me to imagine how you would version control and then diff those things, diff 2 pictures. So it's supportive of version control with tools like Git. dbt is supportive of different development environments. We'll see an example of that in a moment. But the big idea is that if I'm developing, and my colleague Simon, who's on the call, is developing, we don't want to be both building tables and views in the same place in the database. So instead, DBT is really supportive of this environment-based kind of sandboxing where I write all of my models to a schema called DBT Banin, and maybe Simon writes all of his models to a schema called DBT Simon. We can develop independently without stepping on each other's toes. The really great part about that is then there's the notion of the production environment. And so you do the same DBT run over all your models, and you create those tables and views in a schema called analytics, for instance. And I found out that I should not speak about SSIS until I learn more. Sorry about that. Anyone who's so great. Okay, DBT is supportive of sort of creating different development and staging and production environments, which is really important for a healthy application or a healthy analytics development workflow. And then automated data testing. So DBT has kind of two approaches to testing. One is sort of what we call a schema test. It's the idea that modern warehouses do not support like column level constraints like you might find on Postgres or MySQL. I think on Redshift, you can create them, but they're not enforced. And I think Snowflake doesn't have them at all, or nor does BigQuery. Or Snowflake might, but they're also not enforced. So we call these schema tests. It's saying, make sure that every value in this column is unique or not null, or make sure that there's a foreign key relationship from this column in this table to this other column in that other table. You can test that automatically and get an alert if that constraint does not hold. You can also write custom data tests. So these can be just SQL select statements where you sort of, you write a select statement that selects incorrect rows. And if it returns 0 rows, you know that the test is passed. If it returns more than 0 rows, you know that there's that many failures in your data. So this might be like, confirm that the order total, or you know, like order subtotal plus taxes applied equals the overall order total. And if you run that SQL select statement and you find that there's a mismatch there, you know that there's something wrong happening either with your source data or with your transformations. And also, you know, DBT is supportive of this CI/CD workflow. So in the same way we were talking about different environments, when you create a new pull request, DBT can spin up a sandbox schema, kind of build all your models, run your tests, and then give you a check mark in GitHub, for instance. We'll take a look at that in a moment. And same thing, to deploy this stuff to production, all you do is kind of merge into your primary like trunk branch, and you know, your next DBT run will pick up that code and apply it in production. So you know, it's I think this is changing. I think 4 years ago, a lot of this stuff was controversial. The idea that sort of data analysts would use Git and write really heavy analytical SQL, and that you'd think about really the deployment of your data models. Like it was a lot of ad hoc kind of copy and paste deals inside of specific reporting. But these days, a lot of this feels way less controversial. And sort of we're doing cool things to innovate in this space even today, and we could talk about that at the end. So sort of the big underpinning of DBT, that is just SQL. And so this question, like, why is SQL the language? You know, there's Python, there's certainly a lot of people write Java for data intensive tasks, you know, Spark type things. So the reality is SQL is the lingua franca of analytics and has been for decades, since like the Stonebreaker days. It's SQL's got staying power, you know, it's been here for decades. We think it'll be around for decades more. SQL's very much powerful enough to get the job done for both data transformation and sort of analytical use cases. And so these are things like window functions, complex aggregates, even user-defined functions. And there's kind of new and cool things happening in some specific data warehouses that we can talk about too. So I have yet to find a sort of legitimate data modeling or sort of business intelligence use case that you can address in SQL in some way. And I think that the benefit of having it, you know, be just SQL really outweighs the sort of complexity that might come with doing this in pandas or a Spark data frame or something like that. It's very accessible to even people that are newer to, you know, effectively programming, which is, you know, if you're writing code or you're programming, still very accessible in a way that getting your development environment set up to run pandas, you know, in Python is a lot more challenging. And that ultimately is kind of the big thing. It's the great thing about SQL is your machine, your computer is a client. And so you don't need to have, you know, 64 gigabytes of RAM on your laptop if you want to analyze a or transform a 64 gigabyte data set. You just need to make sure that your data warehouse has enough memory. And so that's sort of different than what you would find if you were trying to do this stuff in, say, pandas on Airflow or something like that. So that's really a huge benefit, is that because your machine is the client, you don't need to be set up for kind of beefy computation locally. You just need to be able to execute queries against the data warehouse where that data actually lives. And again, yeah, it's SQL, easily diffable and version controllable. If you look at a diff between two files, like the new version, the old version, it's pretty easy to see what logic changed and how it might have changed in a way that really is very, very helpful in an analytics capacity. So this is the part of the show where we're going to do a little bit of live coding. In 2019, I wouldn't have dared try this, but it is 2020, and we're going to go for it. So let's go ahead and create a data model with dbt. Let's run a data test, and then we'll kind of explore what's happening inside the database. So can everyone still see Chrome, and specifically what might look like an IDE at this point?
Yes. Yes,
perfect, thank you. So I guess it's not live coding, it's more live running at this point. I already wrote a lot of the code. So we're going to take a look at this quick example, and it kind of mirrors the type of thing that we're doing at Fishtown Analytics to calculate our own monthly recurring revenue. So I've got kind of two different schemas set up. This one's called QuickBooks Inc., and I've got another one called QuickBooks LLC. The idea is these two tables have, and the table is the customers table. So these tables have the same schema, but they have different data in them. And the idea is, well, we had one QuickBooks account, we became a new type of corporate entity, and we created a second QuickBooks account. And now we want to create this data model that unions these two data sets together, so that I don't ever have to do an analysis where I actually look at each table and stitch them together. So we look here, there's some like quirks in the search data. So for instance, you'll see that in our LLC data, we've got company 2 listed here twice, but one was deleted. And we can see that it has a deleted at timestamp. This might be a little bit small. I wonder if I can make it bigger. How's that? It's a little bit small. So, you know, one of the things we're going to want to do in this data model is maybe clean up some of the deleted values. We don't want to report on those because they're not real customers conceivably. And the other thing to note is that because we have two different systems, you know, each QuickBooks account might have its own kind of auto incrementing ID. We see 1, 2, 3. And then on this side, we also see that the ID starts 1, 2, but here we're looking at company 3 and company 4. So what we're going to find is that when we union these two things together, our IDs are going to conflict with each other. It's going to make it a little bit harder if our IDs are not unique. So we can take a look at our simple model here, and really we can kind of hand wave away the SQL. It's not so complicated, but what we're looking at is we kind of create a new column called data source, where we just make it statically either LLC or Inc. That's going to help us kind of understand where this data is coming from downstream in analyses. Selecting, we're appending these two data sets together using a union all. This is called a common table expression. If anyone hasn't seen it before, it's kind of like a subquery, but they're really great. Recommend checking them out if you haven't seen them before. So we do a couple other things here. We add a filter. So we exclude any deleted at records from both the LLC and the incorporated customers data sets. And I'm going to go ahead and run the SQL, and we'll just take a look at the results. And we're going to do this kind of in 2 passes. So you can see that, perfect, we've got our data source column, LLC, Inc., Inc., LLC. You can see that our IDs are indeed overlapping. But otherwise, you can see that the deleted rows were filtered out, and that looks pretty good to me. So what we can do is go ahead and execute a dbt run down here. You can see I was playing around a little bit earlier. So when we do a dbt run, what dbt is going to do is take this SQL select statement, kind of wrap it inside of a create view as statement. We'll talk about that a little bit more a little later. And we can see, I guess at the highest level, you know, dbt is going to go ahead and create that view, and it happened in half a second. If we actually click into the details, you can see here's the logic. So dbt ran this create view query, and you can see dbt dbanin here is the schema name. This is my development schema. So if I'm doing this, I'm not stepping on some other analyst's toes. This is all in my workspace. You can see here's our kind of logic. So cool, great. We just created a view. It's in development for me right now. But the next thing to do anytime you write code is kind of write those automated tests and make sure that everything's working the way that you think it should. So in DBT, you can do that with this sort of YAML specification in a file I named schema.yaml. You can call it whatever you want. And you can see here, I've got a model. I guess we were looking at stage customers union. So here I'm describing this model, stage customers union. And DBT provides the opportunity to give a description for that model. And I can also enumerate all the columns. So we've got data sources, the data source for the customer, either Inc. or LLC. And then this is kind of a cool one. We've got the ID column, which, so you've got unique ID for each customer. And I can add these tests here really easily. So I say that the ID column should be both unique and not null. We can make DBT kind of assert that that's actually true. And same thing, we've got descriptions for the name and created at columns. We'll see those in a second. So if we click back here, we see we've got a unique and not null test on our ID column, but it's actually not unique. And so if we want DBT to sort of test that for us and tell if it's true or not, we can run this DBT test command. So what DBT is going to do here is it's going to generate a SQL statement that sort of asserts, every value in this ID column is unique. So we see unique stage customers union ID. We can see that failed. There's sort of 2 entries that are not unique. And if you're curious, this is sort of the SQL that gets compiled by DBT. So it's it's counting the number of records where the count star is greater than 1 for any given ID. So pretty simple SQL query. Just tests that the thing I say should be true is actually true. So let's go ahead and fix this. Maybe the thing to do here is to generate our own kind of almost surrogate key, if you will. So here we'll just say that our ID is LLC dash and then the actual ID. And we'll do the same thing here. We'll say Inc dash and then the ID. So we'll go ahead and save this. And you can see that when I run the SQL, our IDs are going to be prefixed with either LLC or Inc. We can see that here. And so now they're all unique. I'm never going to have a situation where, say, if I join on the ID column, I'm going to get a fan out happening because my ID column is non-unique. And we can sort of do a DBT run again. This is going to recreate the view in the database with our updated logic. This should happen pretty quickly. Cool. And just to double check, we can see, here's our prefix on our ID column. And then we'll do the DBT test. And so whereas before this failed, it said, hey, your ID column is not unique, even though you think it is, we should see that both of these pass now, and they do. So this is a great way to make sure that as you're making changes, your changes are having the intended effect. It's also a great way to see that you haven't regressed in some other thing that you've tested in the past. And so in that way, we do say that tests are a gift that you give to your future self. Okay, and the last thing I want to show you in kind of the course of this demo is this dbt docs generate command. Cool. So our docs are ready to go. I'm going to hit view docs here. And this is sort of an auto-generated documentation website created from the code of my project. So here I can see the stage customer union model. You see it's a view. I'm the owner, and this is where it lives in the database and in development. And we can see all of our descriptions dropped in here. Right in line. So description for the model, and you can see this is actually the ID column. You see the type, the description, and you can see these actual schema tests that says this column is unique and not null. So if you're querying this data set, like, yes, I can join on the ID, it's unique, or no, I don't have to worry about nulls in the ID column, for instance. And DBT's actually tested those things and made sure that they're true. So there's, this is going to be pretty simple, I guess, but this is sort of the same DAG view that we're looking at. So as we would build a more complex DBT project, you could see how these nodes connect to each other. We'll talk about that in a moment too. Cool. So I'm going to go ahead and get back into presentation mode. We ran a DBT model, ran some tests, and maybe I've only got a couple more slides. Maybe a good thing to do would be to wrap up, and then kind of, seems like there's a lot of discussion. I would love to talk about your questions. So how does DBT actually work? We'll kind of breeze through this part at a high level. You write the SQL select statement, so we kind of saw what this looks like in the demo. The difference to call out here is this sort of ref function, and this is how you refer from one data model to another. It's what helps DBT build that lineage graph and understand the order in which to run models. So that's writing a SQL select statement. It's basically just SQL with the addition of this templating language called Jinja. Would love to talk about that if anyone's interested. And right, DBT is going to take this pass where it compiles your Jinja plus SQL into just SQL that it can execute against the database. And this is where the sort of environment management happens. So if I'm in development, this, I didn't put the name of my schema here. I just said refer to the orders model. Whereas when DBT compiles it, that analytic schema is based on the configuration of sort of my target that I'm connecting to. So in development, for me, it's DBT Banin. In production, we're going to call it analytics instead. And then analytics becomes sort of the production schema that everyone can select from for BI, analytics, data science use cases. And the last thing DBT does is it wraps your compiled SQL in DDL and DML in order to create these views and tables in the warehouse. So here we're saying create table analytics.user summary as whatever. And in the same way that before, if I'm in development, it says DBT Banin. In development, I would write to a schema called DBT Banin. It would write to my sandbox schema. Sort of the highest level overview of how DBT actually creates these relations in the database. And yeah, we'll talk about this in a moment. There's actually a bunch of different ways you can configure how DBT creates these things. So you can make a view, a table. You can see there's also a way to create these incrementally. And so instead of just recreating a table from scratch every time, what DBT can do is, excuse me, sort of the first time you run a model, create a table, and then on subsequent runs of that model, DBT can insert into the table, or really upsert into the table. We call that the incremental materialization, and that's sort of appropriate if you're working with a very large data set of sort of immutable historical events. You can just sort of incrementally transform data and insert that transformed data set into your destination table. Really cool other materialization built in called the ephemeral materialization. This is kind of cool. DBT will compile that logic in as a subquery instead of actually creating an object in the database. That's cool for kind of intermediate transformations that you don't want to stick around in your database. And more. So, I mean, huge shout out to Alex Higgs and the folks at Data Vault UK. These folks wrote some custom macros, things like that, materializations that help apply a Data Vault modeling methodology inside of a DBT project. So you can really customize this exactly as you need to and either fundamentally change the way that DBT builds objects in the database. You can also sort of template out the SQL that DBT compiles to apply either a modeling technique or sort of prevent yourself from rewriting the same code in many places and adhere to the sort of don't repeat yourself principle. So yeah, you can create your own custom materializations too. And thanks for the link, Will. That's perfect in the chat if you want to read more.
We've got a lot of people in participating at the moment. We're going to suggest we stick to the chat so people can log questions in the chat. We can run through that and take questions through that route.
Cool.
Yeah.
So yeah, this is, I think, is my last slide. Where's DBT going? Actually, I've got two more. Where's DBT going? So you saw me using the IDE and DBT Cloud. This is sort of an integrated development environment for writing DBT code and running it and sort of doing the Git version control flow all in a web IDE. We actually just released a really cool new feature that we're calling exposures. The big idea is that DBT can have an understanding of where you're querying models from, if it's a dashboard or an ML model or an operational use case. You can use it to answer questions like, where's this model queried from? Who owns the dashboard that is powered by this model? Or if I change the schema of this model, who's going to be mad at me? Things like that. Also kind of on the near term roadmap is we're marching towards DBT version 1.0. So that's all about stability and maturity. And right now we're at version 0.18.1, I think is the latest release. And that'll hopefully be a series of pretty small changes, but we'll have the 1.0 version number to go from. And we're doing a lot of work and thinking about metadata. And so I unfortunately don't have a lot to tell you about that today, but what I can tell you is that we're having a Coalesce conference we're having a conference called Coalesce in December. It's sort of a DBT analytics engineering, ELT user group community meetup. And it's going to be all online over the course of kind of a full week. So I encourage you to join if you're interested in hearing more about this. I'm going to be giving a keynote presentation kind of on this topic. So it's pretty exciting. I think this is actually my last slide. Some trends I'm excited about, but maybe we'll come back to that at the end. And then here's the sort of link if you do want to find out more about Coalesce or sign up and join us at the event.
Thanks, Drew. That's been very, very interesting.